Hello everyone, welcome back to SQL Age, your go-to channel for learning SQL Server practical way. In this video, we will explore one of the most useful categories of built-in SQL functions, the mathematical functions. These mathematical functions are used in almost every organization for the things like calculating bonuses and incentives, adjusting prices or discounts, rounding of amounts, performing numeric transformations. Right, so in healthcare domains, we'll be dealing with the various amounts like claim amounts and then discounts, and then we'll be having the interest and all. Similarly, in banking sector, we know the banking sector is almost dedicated or related to amounts related calculations only. So these mathematical functions are useful in banking sectors, healthcare sectors, as well as in finance sectors as well. Right, so let's jump straight into the SQL Server Management Studio and explore them one by one using the same employee table data. Right, so we are using the employee table from the very first video on this SQL Server built-in function. So we'll be using the same employee table. We have the employee table, and in that employee table, we have the details, field details such as employee first name, last name, hire date, birth date, email, salary, and the gender. Right, so we have seen the built-in functions can be seen in any database. So as we are in student database, expand the student database. Under the programmability, you will see the functions folder. Under the functions, you will see there are system functions tab, right? So if you expand the system functions, you will see there are a variety of subcategories are present there: aggregate, configuration, cursor, state. So we have seen till now aggregate functions, date and time functions. Then we have seen the string functions. Today we are going to explore the mathematical functions in SQL Server. So let's see all the functions inside it. We are having these many functions which are listed here. We are going to see some of the functions from this list, like absolute. We have the ASCII, ceiling, then we have the log, floor, radians, rand, round, sine, square, and square root functions. Right, so let's jump into the demo and see one by one all the functions. The very first function we are going to start or going to see today in the mathematical function is the ABS. ABS is a absolute function. We call that as a absolute. So you know, in mathematics, absolute keywords is used to return a positive whole number always, right? So whatever the value you will provide to this function, it will always returns a positive value or a positive number for the given input, right? So this ABS function returns the absolute, that is nothing but the positive value for a number. It's a very useful when calculating the differences, deviations, or profit and loss, where you can't want a negative value, right? Where you don't want a negative values, right? So we know, like we have the losses which can be like a negative, or maybe the differences or deviations, but while representing that, we should always have that value as a in a positive sign, right? Because we'll be having the column name as a loss and the value will be 400. So in the loss column, we don't again want minus 400 as a loss value, right? So in the loss, whatever the values we'll be having, that will be always positive values. So any calculations we got as a negative, the absolute function will always convert that values into the positive number, right? So let's see, I have this minus 400 as a profit loss, and when I'm convert using this absolute and bracket, in the bracket we need to give the value. So in ABS and in the bracket, when we provide a value, it will always return a positive number, right? You can see when we have the direct value minus 4500, it is showing with a negative sign, but when I use the ABS function for the value, it is showing a positive value here. So the ABS is used to convert your number always in a positive value, right? So in a financial report, if profit is negative, we might still want to display it as a positive number for better readability, right? So we use this absolute function in our logics, in our procedures, to convert the negative values into a positive value. The second important function in the mathematical is a ceiling. So ceiling always rounds a number up to the nearest whole number, right? So you can see the definition here. It will always rounds a number up to a nearest whole numbers, right? So whatever the decimal number we are giving as an input, it will round up the value to the nearest whole number, right? Whole number is in the sense it is a number without any decimals, right? So if your HR system calculates the leave balances as a 7.2, okay, let's say your leave balances is calculating 7.2, but we might want to round up to like 8 or 7, right? So ceiling, what it is saying, round up the nearest integer, right? So ceiling is used to round up the value, but 7.2, whether it will be rounded up to 8 or 6, that we need to see, right? So let's say select ceiling and 7.2. So when we use the ceiling for the 7.2 value, what will be the rounded value we will be getting is a 8, right? So why it is getting as a 8 and not a 7, right? Because if you see, it is the name here, it is ceiling. So ceiling is like always the higher rounded number. Okay, so whatever the value you will be giving, you will get the higher, or we can say the bigger rounded up number. So 7.2, it will not go down to 7, it will always go to 8. Okay, similarly if you have like something 6.9 as well, 6.9, it will not go to 6, it will go to 7 only, because it is a ceiling. Ceiling is like we have the ceiling in our house, ceiling is at the top, so top is nothing but the higher value, right? So ceiling will always give you the rounded value which is bigger than the given value, right? Bigger than the given value, right? The reverse of the ceiling, we have the floor function. Now floor, you can imagine what is floor. Floor is like giving the rounded up value, but the smallest than the given input value, right? So if you use the same values here, we can see rounded down we can use, right? So down in the sense it will always give you the rounded value, but smaller than the input value, right? So 7.2 will be rounded up to 7. Sorry, I'm using the ceiling function. I need to change the name of the function as a floor, right? So 7, I will run 3 together, right? 1.9, 199.99 will be rounded to 199 and not the 200. Even though 200 is near to this, it is rounding up to 199 because we are using the floor function. Same 7.2 will be rounded up to 7 and not the 8. Same 6.9, we know the 7 is nearer to this, but it is still rounding up to 6 because we are using the floor function. So floor will always round the value to the whole number which is smaller than the given input value. Okay, then next we have function as a round. So round function gives you full control over the rounding up or down based on the decimal places. So round, no matter whether it is down rounding or like up rounding, right? So we can do both using the round function, and it will have the control on the decimal places as well, right? So it is commonly used in salary, tax and billing calculations, right? So what we can do here is we can decide how you want to round the given value, right? So let's say we have this here round. Okay, what I'm having here is 1234.56, and I'm giving the another value here. What is that? Another argument here for this round function. So this -2 will decide up to what decimal you want to round up the value. So as I'm given the -2, so from this decimal point the last two digits will be rounded up because I have given the value as a -2. So this second argument for this function will decide up to how many places you want to round up the value. Okay, let's say I'm rounding to the +2. What will happen now? 1234 will be remains there, and this value 56 will be rounded up to 00 or something, 5056, right? So we'll be getting the 56 after decimal point. Okay, let's say I'm using this round value to something like, okay, let's say I'm having the value like 789 something. Okay, we have the 5 digits after the decimal point, but still I want to round up to until only 2 digits here. So when I run this, I will get this as a 0.57 because 8 is there and 896 will be like rounded up to 57 there. We can see that 57000. So this 2 will decide how many decimals you want to round the value for. Okay. The next mathematical function we have is the power. Power, we know this is an exponential, right? In mathematics, we use this exponential. This is the power function raises a number to a given power. So we can give a power and it will be raising the number to that given power. The function requires two arguments. The first argument is like for which number you want to give the power, and second is the power you want to give unto the given number. So 5, I want to give the power 3 to the 5, right? So it will give me the answer as a 125, and we can see that, right? So in business, this power function can help to forecasting exponential growth or depreciation. Okay, if you view the power in negative, it will give you some other value, right? So if you want to forecast the growth, you can use this power function. Next function we have is a square root. Square root is used to calculate the square root of a given number, right? This is a common in statistics or the performance analytics, right? If you want to find out the square root, it will give you the square root. We know square root of 81 is 9. Same way, if you use some other number, like let's say 100, we know like it will give you the square root of 100, right? So 10. Okay, same way, let's say if you want to use something 105, some odd number you are using, it will give you the square root for that number in a decimal points, right? So now we have the decimal, and let's say you want to round the value. So let's say you want to see the floor of this value, floor of this calculated square root. We can combine the multiple functions together as well. Okay, so it will give you 10. If you use the opposite of this ceiling, it will give you 11 there, right? So multiple mathematical functions can be also combined together to get the appropriate result of our query, right? So we can use it to calculate standard deviations or distance based metrics in analytics report. The next function we have is a sign. Sign returns a sign of a number, right? So sign will be like always what is the sign we are having for this for a given number that will be calculated using sign function. These are very rarely used, right? So but yeah, in banking sectors we use these sign functions. So sign function tells whether a number is positive, negative, or 0. So it will return possible there are three possible values. It may return 1, 0, or -1. Whenever a value returns returned by this sign function is 1, which means the given number is a positive. When it is returning 0, the given number is 0, and -1 if it is returned, the given number is negative. I have three values here, 25000, 0, and -400, and we can see when I run this select command, it will return some 1, 0, and -1. Right? You will be saying like, we know this value, then why we are looking? Okay, but this will be useful when we are using the actual column values. Let's say select star from input data. Okay, and you want to see the salary, sign of salary column. Okay, sign of salary, right? We don't know how many records are there. I will just give the name as a sign value, and we can see for each salary, right, it will return some sign value. As all the salaries are in a positive values, it will return the 1 only. If any salary is 0 or minus in a negative sign, it will return 0 or -1, right? So this will help to identify if a transaction was a profit or loss, or if a stock quantity with a negative value, right? So in the real-time table structures, this will be very useful. Okay, because here we were using just standard or the hard-coded values. We may know like this is a positive, this is a negative, or this is a 0. But when we use that at the table level, it will be very useful to identify whether the transaction or the salary is in negative, positive, 0, or any other values we are having in between, right? The next mathematical function we have is a rand function. So rand is used to generate a random number. This is again most useful function in a mathematical function, where we can generate a floating point number between the 0 and 1, right? So it will always generate a random number between 0 and 1. So by multiplying to that random number with any value, we can always generate a unique record for the orders, for the claim numbers and all, right? So we can generate any random integer value with any range by multiplying with the rand value, right? So when I run this select rand, it will always generate a new value. You can see in the result, it is always generating a new value which is between 0 and 1, right? So if you want to generate a random integer, say between 1 and 100, you can multiply and round this number. Because why we need to round? Because the rand will generate the number in some, it is not a what we can say rounded value, right? So we can multiply this round function with 100. We can take the floor or ceiling, anything, and add the +1. It will always generate a new random value between 1 and 100, right? If you change this 100 to 1000, it will generate a random value from 1 to 1000, right? We can see it will always generate a random value between 1 to 1000. Same way, if you add one more zero, it will just generate the value 1 to 10,000, any value, right? So this is how we can generate a random integer which can be useful to randomly pick the employees for a surprise reward for in a HR system and all, right? Then next function we have is a square. Square is this square function is used to calculate the square of a given number, right? So we can pass any number and we will get the square value for that number using this square function. So 9 square is 81. Same way, if you give some other number like 25, it will give you the result of a 25 as a 625, right? So square function is used to find the square value for a given number. The next two functions are related to the mathematical constant and exponential and logging functions, logarithmic functions. First, we will see the mathematical constant pi. So pi functions returns always the value of pi, right? So we know the pi value of pi is like 3415296, right? So it's mainly used in geometry or design related calculations. This is used in like civil engineering mostly, right? Structural calculations where we need to get the value for pi and multiply with some other values, right? So this will be used in structural calculations, civil engineering and all. Okay, may not used daily in HR or finance, but it's still good to know what this pi function will do. The last two functions we have is the exponential and log. These are the functions. These are optional. Again, these are very rarely used in our banking sectors, healthcare sectors, and human resources sectors, but these are useful for data science or analytics. SQL Server also provides these two functions used in mathematical modeling and trained analysis. So exponential 2 will give you the exponential value and log will give the log value for the given number, right? We can see this one. Let's see, we are using our employee data table, and let's say we want to increase the salary by 8%, round it to the nearest 100 and show the difference from the old salary. These three things we have to do on our employee data table. So to increase the salary by 8%, we know 8% is like 8 divided by 100, so 0.8, right? So whatever salary will be getting, that we need to increment by 0.08, right? So whatever the current salary we are having, that we are incrementing by 1.08 and then rounding that to the 2 digits, right, as a revised salary. And to get the difference, absolute of salary, absolute, we know it will always return a positive number, and then round off the revised salary, we are getting the salary difference here. So let's run this query and you will see this is my old salary. After 8% increment, this is my revised salary, and this is the difference of the salary I'm getting when I I'm done with the 8% increment of the salary, right? So round function will calculate the rounded value. This salary into 1.08 will determine the salary is increased by 8%. Then we will be getting the difference between the original salary and the calculated 8% incremented salary, right? So this show how the mathematical functions helps during annual appraisals and payroll adjustments and many more, right? So that's all for today. Let's summarize what we have learned. So today in mathematical functions, we have seen some of the commonly used mathematical functions in a SQL Server. ABS, which is used to get the absolute value. Ceiling and floor, which is used to round up the given value either up or down. Then round function we have seen, which is used to round to the specific decimal. Power, square and square root functions are used for mathematical and geometry to get the square, square root and the power of the given number. Sign functions we have seen, which is used to get the sign of a given value either in a positive, negative or the zero. Then the rand function, which is used to randomly generate a number between 0 to 1, and then by multiplying it with some other number we can generate a integer value between any two numbers. Then pi, pi, exponential and log, those are the scientific functions we have seen, which is used in structural audit, structural calculations and civil engineering. So these are the some functions make a SQL a complete toolkit for numerical and analysis processing, right? So that's all for this mathematical functions. And if you found this session very helpful, hit like, share and subscribe to the SQL Age. Right, in the next video we'll look a group by clause and having clause to see how we use the aggregate functions to summarize your data, and how those group by clause and then having clause is useful to filter out the summarized data in the SQL Server. If you like this video, please share and subscribe to my channel and comment for a new videos like this. Thank you all.